Welcome everyone. It's PM Jarrett of DFI. Today we will talk about upgrade machine of factory for AIoT with machine learning. AIoT, the popular word now, combining AI with the IoT. Let's start with IoT, Internet of Things. Consider about smart home. It's not so difficult and complicated to build up smart home when your house is just new. But it's really a challenge if you want to upgrade or transform existing one to be smarter. You have lots of analog devices to be digitalized. A similar situation when consider smart factory for applying IoT. It's rare to have the chance to build brand new factory and start from zero. You always have old equipment and legacy device for current process and production. It's risky to change architecture dramatically to keep process yield rate stable. What's the challenge now? First, most of factories have been faced with difficulty in legacy maintenance and issues regarding hardware upgrading occur to customers as the old hardware turns EOL. Also, ACRN and PCI I/O card firmware drivers should be modified to support Windows 10, so the manufacturing process should be adjusted with new devices. It's a star case of AUO factory. Still 60% of IPC is Windows XP now, 20% Windows 7, only 10% Windows 10. They even have 10% with Windows NT. AUO already faced the problem of the machine with Windows NT needs spare part, but the board inside was already EOL. DFI helped in resolving this problem by reproduction the board using the stock in DFI warehouse of Intel P41 chipset, which launched 12 years ago. It spent lots of time and effort, and not every time so lucky to find the right chipset stock. If we don't want to face this kind of situation all the time in the future, we need to find legacy devices with Windows 10 compatible and revamp the system and fine-tune the whole process for optimized profile again and again. It will cost a lot to upgrade every IPC to Windows 10, and the process yield rate must be effective. And I believe the management of the factory will not allow you to do that. Remember how we transfer the data between different cell phones in 10 years ago? We need to back up data of old one manually and have data recovery partially in new one. And how much data you could transfer depends on how similar the OS structure of different phones. But nowadays, we could switch data flawlessly between different mobile solutions and device, even between iOS and Android system by using Transfer App. The Transfer App, the middle area, is the key to let hardware and software of mobile devices be independent. You don't need to consider about the compatibility between software and hardware of mobile phone anymore. What if we use middleware to let the hardware and software of x86 platform be independent? Intel using IPC refresh to achieve that. Using virtualization tools like VMware as middleware to virtualize I/O connection between hardware physical layer and software driver layer. Then hardware and software could be independent. Either hypervisor or host mode could both let Windows XP, Windows 7 work on new platform hardware. Set up VMware on new platform hardware, like latest 9th generation Coffee Lake CPU, and load the OS image from old IPC directly. It's not necessary to reinstall OS again on new platform. Here is the demonstration. Extract all image from old IPC through sysprep tool. Transfer and restore the images through disk imaging tool like CloneZilla. Accordingly, deploy in virtual machine, which covers 3 options, including Oracle VM VirtualBox and VMware Player for Windows and KVM for Ubuntu. Then run Windows XP with new IPC successfully. In order to upgrade all IPC with Windows XP or Windows 7 for different legacy I/O and ISA interfaces, which is an old interface, which is popular and applied in some kind of factory. DFI provides embedded motherboards with Haswell 4th generation and latest Coffee Lake 9th generation CPU to support ISA slot. These are DFI's motherboards with Intel 6th to 9th generation CPU, supporting PCI interface and different version of 4 to 6 PCI slots. These are DFI embedded systems with Intel 6th to 9th generation processor, supporting PCI interface and different version of 4 to 6 PCI slots. After upgrading old operating system IPC with new generation CPU by virtualization environment, when getting more and extra performance due to new technology CPU, what you can do more? Intel introduced new concept of multi-virtual machine with independent I/O by ACRN Hypervisor technology. Since Intel provide VT-X technology to virtualize CPU and memory, we already use virtual machine technology in one PC with sharing the same monitor and keyboard mouse for decades. And now, after Kaby Lake, the 7th generation Intel CPU, Intel provide new technology of VT-D and GVT to virtualize the I/O interface. That means different operating systems of virtual machine can control independent I/O interfaces like display and USB, etc. Intel also introduced VT-C technology to provide virtual network connection between different virtual machine operation systems. Now not require extra LAN switch for mutual connection between different operating systems. Imagine that 3 different OS, Windows, Ubuntu, Android, using dedicated monitors and keyboard mouse and COM ports, Ethernet port, etc., with just one single CPU and motherboard. Here is the demonstration of workload consolidation concept with DFI KD331 Kaby Lake board. Provides 3 independent users for 3 monitors, 3 keyboard mouse set in 3 different Linux operating systems. If we hide the motherboard under the table, the 3 different OS users will not be aware of that they are using sharing the same hardware. What we could do more from this technology? Here's the factory automation case. We use 3 different machines for rubber arm, AOI, and HMI in production line currently. If consider about defect rate of this product line, 3 machines must work well at the same time to make this line run. Let's assume some case that the defect rate of each machine is 5%. You will see the defect rate of this line with 3 machines will be around 15%. When using 5 machines at the same time, defect rate will be around 23%. But if we will use workload consolidation technology to apply 1 machine for 3 purposes, 1 real-time OS for rubber arm, 1 Linux for AOI, and 1 Windows for HMI, then the defect rate of this production line with same functionality will be just 5% only. Here's the other case of in-vehicle dashboard and infotainment system. We use 4 different systems for dashboard and 3 in-vehicle infotainment systems in this car currently. If consider about back repair rate of this car, 4 systems must work well at the same time to avoid being sent back to the repair center and factory. Let's assume some case that the repair rate of each machine is 5%. You will see the repair rate of this car with 3 and 4 systems will be around 19%. But if we use workload consolidation technology to apply 1 system for 4 purposes, 1 real-time OS for dashboard, 3 Android system for in-vehicle infotainment system, then the repair rate of this car with same functionality will be just 5% only again. Here is the case for retail store. We use workload consolidation technology to apply 1 system for 3 purposes. 1 Linux for AI surveillance, 1 Linux system for digital signage, and 1 Windows system for POS. Here's the case for casino gaming. We use workload consolidation technology to apply 1 system for 3 purposes. 1 Linux for jackpot, 1 Linux system for player tracking, and 1 Windows system for large box 3D gaming. When applying the workload consolidation to different fields, the different purpose monitors might not be placed in nearby area, so cable length of display will limit the flexibility. DFI provides a monitor plan for workload consolidation. One is HDMI over LAN, extend the HDMI for display and USB for touch via LAN. Another is wireless monitor, extend HDMI for display and USB for touch via wireless Wi-Fi. And now we could talk about AI. AI will be everywhere in the future. AI could be applied to many different areas depending on the needs. Also, different application needs different AI computing performance. So AI everywhere needs more various solutions, and small and friendly systems provide flexibility. For AI cloud server, DFI provides different versions for slot requirement. PR810 with dual Xeon is for 3 to 4 PCI Express by 16 slot. PR600 series with single Xeon is for 2 PCI Express by 16 slot. For AMD series, we have SO630 with single BGA type EPIC CPU for 3 PCI Express by 16 and 1 by 8 slot. DFI will have a new series of mini ITX board with MXM supporting for highly integrated NVIDIA graphic AI system. DFI also have ultra small board series with desktop Core i7, i5, i3. CS551 is in 3.5 inch, and CS251 is in 4-inch board, provide the flexibility of integration of high computing performance. We also provide different box systems for AI application. EC532-KD-AI with desktop Core i is for one NVIDIA PCI Express high-end graphic card supporting external power input. EC500CS-MXM with desktop Core i is for one NVIDIA NSM graphic card and potential option fanless design. EC800-AL-AI with Atom is for Intel Mobidius AI as AI edge computing device. After we upgrade system by IPC refresh with much more powerful CPU, and we virtualize the OS environment to be isolated, what we can do with the extra performance we get? Intel introduced OpenVINO to enhance AI performance of your existing Intel platform. Whatever is the CPU core or integrated graphic, all could be optimized for AI computing. So we could use the extra performance after upgrading system to virtualize and isolate OpenVINO AI computing environment as an external edge computing AI device. Let your current machine be smarter. Intel keep increasing the performance of integrated graphic. This will be a significant AI device after applied OpenVINO. Intel also provide AI accelerators in ARM and FPGA solutions for different AI performance requirements. These are different types of Intel AI accelerators. One Mobidius chips in Mini PCI Express, 2 Mobidius chips in M.2, 8 Mobidius chips in PCI Express by 4 card, Intel Altera Era 10 FPGA in PCI Express by 8 card. Intel also provide lots of AI inference engines sample code in OpenVINO environment. It's free and public, just find the right model and train by yourself. Make machine be smarter, upgrade machine with IPC refresh and the virtualized OS environment with virtual machine. Then use Intel CPU, GPU, VPU, FPGA for AI with OpenVINO. Now make AI everywhere in your application. Thanks for your listening. Okay. 是看一下状况还是？好，先直接结束嘛。好。看看这样录成功吗？
你这边变英文。
因为刚刚要是用英文的那个。